So what does a materials technology company do? Well, that's a great question. So it's very common for materials technology companies to be discovering new materials and exploring for naturally occurring materials, and also in building technologies where you apply those materials, and those technologies fundamentally depend on those new materials, those refined minerals. So it's a really exciting space to be in. I think some household names of materials tech companies, I guess, that you may not be aware are materials tech companies. You have companies like BASF, you have companies like Siemens, and other multinational, very large companies where specific business units are dedicated to materials technology. GE is one example. You have Intel. So all these companies engage in materials technology. And I guess one of the unique features about a materials technology company is you can exercise the strategic option of having multiple commercial pathways to profitability. And that's entirely possible because materials are the tangible physical basis of all technology. And so, in a way, it makes materials technology companies quite exceptional. Okay, so what do we do at Archer? Okay, well, we're a materials technology company, and we explore for minerals, we discover new materials, and we find new and exciting applications for these new materials, like in quantum computing. Some of the materials that we work with include carbon-based qubits, graphene, electrode materials in lithium-ion batteries, and we explore for minerals like gold, copper, and nickel here in Australia. Well, the question that I ask myself whenever I get asked this question is a very simple one. Do you think computing power in the next, say, 5 to 10 years is going to increase? And I definitely believe it will. When you dig deeper there into that question, it's really how are people going to achieve this? How are companies and organizations going to achieve this increase in computational power? Well, quantum computing represents that next generation of powerful computing. At Archer, we are building a qubit processor. The qubit processor is the brain of the quantum computer. Without a processor, you simply don't have a quantum computer. So it's a fundamental aspect and component of quantum computing. It's the hardware. So this hardware is made up of materials, and these materials need to be able to store and process quantum information. And to do that, you need materials. And we call these qubit materials. So at Archer, we're working with a qubit material that has the proven potential to operate at room temperature and to allow for onboard integration in modern day devices. Now, technologically, that represents a paradigm shift. It really combines the disparate fields of quantum computing that rely on doing quantum computing at really low temperature. And again, this is a limitation based on the materials that are being used. It's not a simple design parameter fix, right? So you have materials where when you use them to process quantum bits, you need to do this at really, really low temperature. And because of this, you need that infrastructure, very bulky, very expensive infrastructure that just makes doing it on board your laptop and phones not practical. The other approach in quantum computing has been to use materials that you can do quantum computing at room temperature with. However, they're very difficult to integrate, again, into modern day devices. They may rely on massive optical setups, or there may be a portion of their technology that requires them to be cooled down to really low temperature, even though the quantum computing is done at room temperature. So with our solution, we have the potential to overcome these problems. But really, they're the technological issues. I mean, the technology obviously is at the heart of materials technology, is where the value is derived. But when you dig a bit deeper again, you'll find that by overcoming these technological issues, what we actually offer is being able to apply an existing business model in the semiconductor industry to quantum computing. Right now, because of the materials that are being used, quantum computing is limited in its use, it's limited in its ownership, and that means its reach and its market and its opportunity is limited. Because of these big, bulky and expensive apparatus and infrastructure that's required, currently you're able to only really employ cloud-based access solutions, cloud-based business models to use and to get that value out of quantum computers. Now, with the development of onboard room temperature-based quantum computing, the business models that you can apply are the ones that Archer is applying, is where you build the chip and you sell it. And also to sub-license out the aspects of the IP where it's useful to do so to generate revenue. So we've recently signed a quantum computing agreement with IBM, and this is fantastic news for Archer because we're now able to collaborate with IBM, and we've also been invited to join the global IBM Q network as an ecosystem partner. We are the first Australian company that is building a quantum computing processor to join the IBM Q network, which is absolutely fantastic because it's a network that's made up of pioneers and companies at the forefront of quantum computing in the world. What we look forward to working with IBM on is integrating their software development kits with our hardware. And really, that is at the core of what we want to get done first and initially. And we very much look forward to doing this with the teams at IBM and those within the IBM Q network. So what is quantum computing going to be used for? That's the billion-dollar question, isn't it? People ask me this question all the time, the way I respond is I say, yes, quantum computing is promising all these amazing things to enable, AI to exponentially speed up. They're talking about, driverless vehicles. We're talking about new drug discovery, efficient drug discovery, talking about discovering new materials that can solve for our energy problems. Really, the opportunities seem quite limitless. And the short answer to that is, yes, it's entirely possible that quantum computing can do all these things and more. There are algorithms currently being written and algorithms that have been written that show that it is entirely possible that with the development of quantum computers that we can get more powerful computing to do even more with our technologies in the world today. So it's very exciting. But the one thing there to remember is you need a processor. You need a quantum qubit processor to run these algorithms in order to realize these fantastic benefits of quantum computing. And at Archer, we are very well placed to build and commercialize our quantum computing chip. And we have very robust agreements in place where we're actually building the chip. We're building the chip here in Sydney at the Nanoscience Foundry. It's a $180 million purpose-built facility for doing these kinds of things. And so we're very determined to do so, and we've been doing very well over the last year in really advancing the development of our prototype and assembling the key components of our 12CQ processor. Graphene. Oh wow, okay. Now you're taking me back to my undergraduate days. I think it was probably about 10 years ago now that I was officially the first person to make graphene by not using graphite, believe it or not. I was able to just simply use alcohols in the lab to produce graphene in in very large quantities. At the time, that was a paradigm shift in the field. Now, I guess, at Archer, we're using graphene because it is a material that, well, it's the thinnest material known. It's the thinnest material known. It's an ultra-sensitive interface, and at interfaces is where chemistry occurs. And so when you have this ultra-sensitive chemistry that you can use for sensing, in biosensing, that's essentially all you do. So in that regard, graphene is actually quite ideal for use in biosensing. But at the same time, there's a deeper rooted issue that we're solving for here, and that's that in biosensing, you think about the vastness of the entire universe, right, and the planet. There's only a handful of materials that can actually be used to sense at the molecular level. And that greatly restricts the type of disease detection that we can perform as human beings. So, finding new materials, unlocking new materials, and applying them in biosensing has the opportunity to impact global multi-billion-dollar industries that are reliant on a key component that performs that biosensing. So at Archer, what we're doing is we're making graphene, and we then integrate this graphene and these modified forms of graphene. We do some special chemistry on these materials that are then able to be printed and produce these sensors ad hoc. Essentially what we're doing is we're digitizing the manufacturing process of key elements of a biosensor that would allow for very complex disease detection. So it's a very exciting field to be in, and really the value is coming from the atom scale, very small scales that we're working at, and we're pushing those boundaries of what we can achieve in biochemistry and advanced manufacturing. So, that's all great technically, but commercially, what we aim to do with our biosensor technology, really, graphene it's creating opportunities. It's creating, as I was saying, there's only very few materials out there that can do this complex disease detection. So by using graphene, we're essentially creating a very, very important competitive advantage that we need to be able to protect. And one way that we can protect this competitive advantage is through filing patents and really going through that patent application process and building that IP portfolio that we can then license out to generate revenue. Okay. Yes, definitely. We do want to grow our reliable energy business unit, and this is a area that we are actively working to develop. I think there's no doubt over the last 2 decades that there's been a paradigm shift in the way people hold each other to account when it comes to energy consumption. We're seeing that, and there is a lot of consideration now for the negative human impacts on our environment due to this growing demand for energy. So really, when you look at it from a materials perspective, materials seem to be the problem and the solution to our energy needs. And we need to be able to find more materials, new materials that are capable of addressing the trade-off between energy and the costs associated with that commodity. And to do that, we really do need a more sophisticated approach to materials discovery. And at Archer, this is what we're doing. We are combining the old traditional ways of materials discovery, where there's hands in gloves in the lab, but we're also complementing that with high-powered computing, quantum computing, in order to sift through the massive and tremendous amounts of possible formulations for materials that can be applied in technologies like lithium-ion batteries. So it's something that we are working on, something that we are developing, and we're very much looking forward to growing that IP portfolio of new materials that we discover that we can then work with partners in the energy industry to license this IP and to develop these materials and integrate them in technologies downstream, like electric vehicles and like portable electronics. So as a materials technology company, I do believe that it's a good economic decision to secure critical materials in the supply chain, strategic materials in the supply chain. So in Australia, we have a wonderful wealth of mineral resources. And at Archer, we have a very broad scope tenement portfolio for exploring for these critical and strategic minerals. In Australia, it is an industry which does provide so much for people and the economy. So again, I think it's a good economic decision to be engaged in mineral exploration. And our key focus in mineral exploration and our commercial pathway there is in developing our prospects, looking for materials that are in demand, and then adding value and monetizing these assets. So, at Archer, we do, have that broad scope tenement portfolio where we have district scale kind of projects all the way through to resources. So it's quite exciting. We know that mineral exploration is high risk, but there are very important minerals that we want to be looking for and that we want to be securing because we believe that future economies are going to be dependent on these mineral exports. Well, I mean, yes, it's true. And this is what I was talking about earlier with having that opportunity and that option to pursue multiple commercial pathways along the materials life cycle. There's no one thing or another that I look forward to as much as I look forward to as a collective at Archer for us achieving what we set out to achieve. But if I did have to pick one, it would be definitely working with IBM and members of the IBM Q network and getting that control componentry of our 12CQ chip assembled and working. I mean, that would be absolutely phenomenal, I think, from our standpoint.